I am Dr. Ananta Yambi, Professor and Head of Civil Engineering Department, SVIT, Bangalore. See the subject analysis of determinate structures, Module 3, deflections, a numerical on moment area method. First we will see the problem. Determine slope and deflection at points B and C for the cantilever beam shown. See, this is the cantilever beam AB, AC. See, this point is A, B and C. The length of the portion AB is 2 meter, BC is 2 meter. Two loads are acting. One is 5 kN at B, 10 kN at C. Again, the flexural rigidity is given. For BC portion it is I, for AB portion it is 2I. See, for cantilever beam, always I am moving from right to left for the calculation of the bending moment. Therefore, I am considering right sign conventions. So, it is clockwise negative, anti-clockwise positive. Now, we have to calculate the bending moment. How to calculate the bending moment? See, I am calculating first the bending moment at C. That should be equal to 0 at the free end. Next, I am calculating bending moment at B. Means my section line is at B. I have to consider portion right of this, means portion BC. Therefore, what is the moment due to this 10 kN load is 10 into 2. It is clockwise. 10 into 2 clockwise. 10 into 2 clockwise. So clockwise to the right it is negative, hence it is minus 20 kN meter. Now moment due to 5 kN is 0 about By, because it is acting at the same point. The distance is 0, therefore moment due to this force is about point is 0, that is not considered. Now we have to calculate bending moment at A. For this we have to consider the portion section line at A, and we have to consider full portion from A to C. Therefore, first we will calculate what is the bending moment due to this 10 kN load. 10 kN load is acting here. This will create clockwise moment about A. Therefore, 10 into 4, distance is 4, minus 10 into 4. Why? Because clockwise is negative. Next, 5 into 2. This 5 kN into distance is 2. This also clockwise. Therefore, minus 5 into 2. Total we are getting 50 kN meter. Now I have to draw the bending moment diagram. So this is the reference line AC where bending moment is 0. See, bending moment at C is 0. B is minus 20 kN meter. Minus means below, plus means above. It is minus 20 kN meter. At A it is minus 50 kN meter. So total bending moment diagram is negative. Therefore it is called bending moment diagram, BMD. Now I have to draw M over EI diagram. EI diagram. See, all the values, if I divide it by EI, it becomes M over EI diagram. See, from here to here, B to C, it is flexural rigidity is I. The flexural rigidity is I. Therefore, what is the bending moment diagram? I am doing 20 by EI because it is single I. 20 by EI, it is same for B to C. But in portion A to B, it is 2I. Therefore, I have to divide all these values again for portion BC by 2. 50 by 2 is 25 by EI. Again 20 by 2 is 10 by EI. 10 by EI because AB is 2 EI. Therefore, again I am marking this 10 by EI point also. Then I am dividing this. See, if I am drawing a horizontal line for making this as a regular shape rectangle, this is also 10 by EI. Total is 25 by EI minus 10 by EI is remaining 15 by EI. Again I am joining this. I am dividing this diagram into one rectangle, two triangles for the calculation purpose. Again I marked the CGs of this triangle. From here it is 2/3 of 2. From apex 2/3 of 2. From base it is 1/3 of 2. I marked the CG of this. Again for the rectangle the CG is at the center. So from here total is 2, means from here to here 1, here to here 1. Again this is also a triangle. From apex this distance is 2/3 of 2. From base it is 1/3 of 2. This is called M over A diagram. Now we will calculate the slope at C. Now I am calculating slope at C, that is theta C. This is the given beam. See, if this beam up to certain length along with the horizontal, then it deflects. So I have to calculate, if you draw a tangent at this point with respect to horizontal, this angle is theta C. We have to calculate this theta C now. This is deflection delta C. Afterwards we will have to calculate. this deflection is delta B and this is theta B. First we will calculate slope C. The first moment area theorem tells the difference in slope between 2 points. I am taking for calculation of the slope at C, one point is A and one point is C. The difference in slope between points A and C, that is theta CA equal to theta C minus theta A equal to area of M over A diagram, between the points A and C, whole area if you add, that gives the theta C minus theta A. Now what is the area of this rectangle? 2 into 10 by EI. Since the negative values, all the diagram is negative below, I am taking with the same sign, negative. Next, this is next area is this triangle I am taking, half into base into height, half into 2 into 15 by EI, half into 2 into 15 by EI. This area also over, this also negative, I taken with the negative sign. Next, this triangle, half into 2 into height, so half into 2 into 20 by EI, half into 2 into 20 by EI. I calculated this came nearly minus 55 by EI. Now we know at fixed end theta A is 0 because horizontal line and tangent are coincides with each other, therefore theta A equal to 0. If you, in this equation, if you make theta A equal to 0, directly you are getting the theta C is 55 by EI, because in cantilever beam directly you are getting the answer for the slope. Next you will calculate slope at B, that is theta B. So here difference in slope, again I am taking the points A and B now, because in the beginning I had taken A and C for calculation of slope at C. Now I am taking points between A and B, therefore difference in slope between A and B, that is theta B minus theta A equal to area of M over A diagram between these 2 points, means this rectangle and this triangle. See, I written here difference in slope between points A and B equal to theta BA equal to theta B minus theta A equals area of M over A diagram between points A and B. Here area is one rectangle and one triangle. See, what is the area? See, rectangle area is 2 into 10 by EI. It is minus 2 into 10 by EI. Another is area of this triangle, half into base into height, half into 2 into 15 by EI, half into 2 into 15 by EI. I got, since theta A is 0, directly I am getting theta B equal to minus 35 by EI. I calculated slope at 2 points. Now we have to calculate what is the deflection at point B and deflection at point C, delta B and delta C. Here directly we are getting the answer. Now you see I am calculating deflection at point B, delta B. It is delta B. So the second moment area theorem tells deflection, the deflection at a point with respect to tangent drawn from any other points. That means what we are doing, deflection at point B with respect to tangent drawn at point A equal to moment of M over A diagram between points A and B about B. That will give you the what, direct deflection. See, deflection of point B with respect to tangent. Here tangent is horizontal, directly we are getting the deflection. Deflection at point B with respect to tangent drawn at A equal to moment of M over A diagram between points A and B about B where deflection is required. Therefore delta BA, deflection at point B with respect to tangent drawn at A equal to, what is the moment of this rectangle A and B? Here A and B there are 2 areas, one rectangle and one triangle. Now here it is 2 into 10 by EI into CG distance is 1. So 2 into 10 by EI into 1 from B. Next, half into base into height, half into 2 into 15 by EI into its CG distance from B is 2/3 of 2. We got it is 40 by EI. Therefore delta BA is 40 by EI. We got the deflection. Similarly, I have to calculate deflection at point C, that is delta C. Deflection at point C, that is delta T. That means deflection at point C with respect to tangent drawn from A equal to moment of M over A diagram between points A and C about C. See, deflection of point C with respect to tangent drawn from point A should be equal to, that is delta CA equals moment of MOREI diagram between points A and C about C. Now between A and C there are three areas, one triangle, rectangle and triangle. We take the moment of all these areas about C. Therefore moment of this rectangle is 2 into 10 by EI into its CG distance from C is 2 plus 1 minus 2 into 10 by EI into 1 plus 2 or 2 plus 1 minus this triangle half into base into height half into 2 into 15 by EI into its CG distance from C is 2 plus 2/3 of 2. 2 plus 2/3 of 2. Now one more triangle is remaining here. Moment of this triangle half into base into height half into 2 into 20 by EI into its CG distance from C is 2/3 of 2. It is 2/3 of 2. From this directly we are getting deflection at C delta C equal to minus 136.67 by EI.